Listen, we'll try to conduct two experiments today, if possible. And I have given you the idea about transformer, right? Last class.
Yes, sir.
Yes, sir.
Wave shapes. Another thing that is basically we need to conduct this experiment. The first is rectifier circuit. So rectification is a process by which we can convert the alternating current, this alternating form of current into pulsating DC, not exactly DC, pure DC, pulsating DC. So listen, so it can be two types. One is half-wave rectifier, another is full wave.
আমি চিন্তা করছি আপনি কতক্ষণ থাকবেন
ভিডিও করে আছে
Full wave is again two types. One is
YouTube channel
full wave
upload করতে
center
সবাই
type.
কাজে দেয় ওটা দেখলে বাসায় ভালো
Yeah. And another is full wave breeze. So let's see how each and every works. Okay, listen. First, half wave. Half wave, it is regarded like okay. Let's see input signal for all. So this is what the input, like the line current that is available for us. And our job is just to first job will be this voltage is too high. It is 220, but our device requires some 9 volt or maybe some 6 volt or so. So our first job is just to step down this higher potential, higher voltage to lower voltage using a transformer. So the transformer looks like that. I've talked about the transformer. Did I discuss about that last class?
Yes.
Okay. So that's what a transformer looks like. So if it is a half-wave rectifier, we will use only one diode. This one is only one diode, and then a resistor. That's what makes half-wave rectifier. And now, if it is okay, then see how full-wave rectifier looks like. Full-wave center tap. Okay, this one, the output of this one will be like this. All positive, and also the output of this one also will be looking the same. And now why they have got different name then? Actually they have got different uses, that is why different name. The first thing is if we connect full wave center tap. Okay, why center tap come into force? Let's see. That's the supply, higher potential, and then it will be stepped down to some lower voltage. So this terminal of the transformer is called center terminal, and once you are taking the voltage from that terminal, then it is called center tap. And again here, if you look at the wave breeze, then you see this time they do not use any center terminal of the transformer. Okay, if you look at the transformer, you see at the secondary of a transformer there are 3 wires. Exactly, the diagram of a transformer looks like this. So secondary will have 3 wires coming out, and primary will have 2 wires. So in these 3 wires, the middle terminal is called tap terminal because it is tapped in the middle. So if we have if it is marked as a 12 volt transformer, which means that's the 12 volt, that's 0, and that is 12. So once you need some 12 volt as output, maybe you have a device that uses 12 volt. So for that you need to take voltage between these 2 terminals, the tapped on and this 12. Then you will get a 12 volt output. So for that, if you would like to rectify for that 12 volt, then you have to use this transformer. That's the 12 volt 0. Within these 2 will take output. Right? But if you need 24 volt, the double to that time you have to avoid this one, just use these 2. That makes 12, 12, 24. So for that we need breeze rectifier. You understand? So breeze rectifier is like here, 12 volt and also 12. So that makes it. So now how would you connect the center tap? Center tap uses two diodes, and then a resistor will be used here. Okay, be connected. So that's how the full wave center tap rectifier looks like, using two diodes only. And full wave bridge rectifier. Listen, this one and this one both will work for same. I mean, both of them are full wave. This portion is for full wave. Only this portion is for half wave. Half wave generally doesn't use much, right? Because the efficiency of that half wave rectifier is half to that of full wave. So everywhere you see the power supply, full wave rectification is used. But as you are learning, you have to learn this as well. Then what happened once we use half wave rectification? Okay, for full wave, the arrangement will be like this. Okay, listen. So this is this 4 diodes make a bridge. That is why it's called bridge rectifier. Okay, now let's see how it would work. For first time for half wave rectification, how it works. Let's see. Think about this is 1 second mark. So within 1 second, there is one positive half cycle and one negative half cycle. That means one full cycle. So if one full cycle completes in 1 second, that makes it 1 hertz, right? Hertz, that means cycle per second. Cycle per second. That means one full cycle containing one positive half and one negative half in 1 second. That means 1 hertz. So think about, we have a signal that has got 1 hertz frequency. So that means this first half cycle, positive half cycle occurs in 0.5 seconds, right? And the rest negative half cycle occurs in next 0.5 seconds. 5 seconds. That means this is how every full cycle will work. So we will work for same here, the same. First half second, positive half, and next half second, negative half. Think about this one. We will work only with one full cycle. That's the next half. And the same for here. 0.5 seconds, and the rest 0.5 seconds. So this is the time exactly. Now let's see what happened to this circuit. When this positive half at the, so time starts from now. So for first point half second, this portion becomes positive. The diode is connected such that this is the P type and this is N type. And N type is connected to a resistor in series connection. This is the higher potential and this is the lower potential of a transformer output. So at this, listen, at this, during this positive half, this portion becomes positive and this portion becomes negative. During this positive, that means the positive will be appearing here, right? During this negative will be appearing here. So up to 0.5 second, first 0.5 second, we'll see this portion becomes positive. The positive with the P type that makes the diode forward biased, right? So there was a question in the first term. How can you make a diode forward biased? So let's say this positive makes this diode forward biased. Okay. So that makes a short. Forward bias means what? It will allow the current to pass. That means it is a short. It's like a wire, normal wire. So it will be a conductor. So as this is a conductor for this amount, this 0.5 second, that means up to this will get at the output, right? So at the output will get something like this. Okay. So first 0.5, that's the first 0.5 second. And next 0.5 second. You consider it is a 1 hertz, right? Next 0.5 second, listen. If during the, okay, this one is exactly looking the opposite to this one, right? Right?
Yes, sir.
Okay. And let's see, if we have a resistor and if we connect this power, this current to this resistor, what will happen? Let's see. During positive half, if you make a circuit like this, having a AC power source, then during positive half, the current will flow in this direction, and during this half, the current will flow to the opposite direction. So forward and backward, forward and backward, forward and backward. That is how it will happen. So every second, 50 times, there is a positive half cycle and there is a negative half cycle. You understand? Okay. So that means what we get? During positive half, we have got a positive half cycle there. And during negative half, listen, during negative half, this is, okay, so as this one is the opposite to this one. So we had positive during this time. So what will we have here for now? During this time, the opposite to that. So what is the opposite of positive? Negative. So this will be negative for now. So as this is the negative, so negative with the p type, what will that be?
Reverse bias.
So reverse bias doesn't allow the electron to pass, electron to flow. That means this portion is not going to appear at the output across the resistor. So during positive half cycle we will get this directional flow. During negative half cycle we will get no flow, nothing. So that means there will be a straight line. And next 1 second. Next there will be another, right? So we will get another positive half and negative half, there will be nothing. So that is how half wave rectification works. Got it? Come to the full wave. Full wave center time. Okay. For full wave, let's see. I talked about this, that we have to make sure that, okay, if this is a resistor, for now the current is flowing. If we apply this current, the current is flowing during positive half, during first 0.5 second. Okay, consider it's the first 0.5 second in this direction and next 0.5 second to the other direction. That is what happening for now. As we are applying it to this arrangement, what will happen? During this 0.5 second, this portion becomes positive and this portion becomes negative. So as this positive with the P makes this diode forward biased, so that means this will allow the current to pass, this portion to pass through. So this way. As it is coming back this way, because this will not flow because this diode is the N, right? So this positive portion with this N type will make it reverse bias, right? So that is not going to allow the current come back to this. So it has only way to flow this way. And through the resistor it is passing this way, right? This way, right? So for this we are getting this portion. Say for this one. This portion. That's the first 0.5 second. And next 0.5 second, what will happen? Let's see. During next 0.5 second, the opposite thing to this will happen. So opposite thing, that means this was positive and this was negative. Now opposite thing means what? This will be positive,
This will be negative.
this will be negative. Right now, during negative half cycle, this becomes positive, this becomes negative. So for now, this one is reverse bias. That means this one is open. There is no connection. But this one will be forward biased to the P positive. So that means this way the current will flow and through the resistor again at the same direction, right? So for that, if we would have this shape, for this the similar shape, right? So we'll get another same shape at the output. So for next half second, we'll get the same thing. So these things will repeatedly happen because next there is another full cycle. So the same two thing will be there, one and maybe another, like this. You understand? So that is how the center tab works. But this time we'll get only 12 volt, 0 to 12. Because the output, other terminal of the resistor come back to the 0. So 0 to 12. That makes only 12 volt. You understand? Okay, now next, this one. Bit similar to this. Okay, how that happens? Let's see. During positive half cycle, this portion becomes positive, this portion negative. So positive here, that means this is the P of this diode. Listen, this is the P of this diode, right? Okay, you come on. Stay here. Okay. I think it's okay. Okay, listen. Do you see that for now? Do you see that for now?
Yes, sir.
Okay. Let's see. When this is positive, that makes this diode forward biased. So that means current. I mean, during first half second, this wave shape is gonna flow this way, and through the resistor it's gonna pass this way, right? So for this we have got this quotient 0.5, first 0.5 second, and during negative half, I mean when this next 0.5 second, this negative appears, that makes this portion negative, this portion positive, right? So as this portion becomes positive, okay, N with a positive reverse bias. So this diode will be reverse bias, this diode will be forward biased. This is P with the positive, right? Do you understand?
Yes, sir.
So the current is going to flow this time this way, and again through the resistor, same direction. That means another similar wave shape. That is how it makes full wave rectification. You understand? Any question on full wave and half wave rectifier?
No, sir.
Half wave is very easy, easier than that. Listen, during positive half cycle, this portion becomes positive and this diode forward biased, and allow this portion to appear at the output. Okay. During negative half cycle, this portion becomes negative. Negative. Negative with the p type makes it reverse biased. Reverse bias, that means what? This is open.
Open, sir.
This is open. It will not allow this portion to pass at the output, so it is nothing. There will be nothing here. And again, next positive will appear, and next negative will not appear. That's something, right? And now one thing that is in the full wave rectifier, we'll see the frequency will be doubled. Why? Because number of cycles. Let's see. Here we have within this 1 second, there is only one positive half, and that's the other half, right? But how many positive half at the output in 1 second? Two positive half.
Two positive.
So whatever the frequency was there will be double to this here. You understand?
Yes.
So that will be an observation that we'll observe that the input frequency will be double to at the output, right? Okay, so we'll work for now. Now your job is just to have a